Good evening, everybody, and I hope you can all hear me. And welcome to the latest in our series of South Georgia Association meetings and talks. We're doing this evening's talk a little bit differently to how we've done the previous ones. So this evening we've got the speakers with me on Zoom, and the talk itself is being broadcast across through YouTube. So we are a little bit more removed, those of us speaking, from those of you in the audience this time. So I apologise for that, but it allows more people to engage with us and to see the talks. This evening you've got myself here, and I will be doing the introductions. Pat Lurcock, who many of you know, is controlling all the technical side of things and making sure hopefully everything works smoothly. There should be an opportunity for you to feed in questions to Pat through the YouTube channel, so feed those in, and I will then field them to so this evening we've got two of my esteemed colleagues from British Antarctic Survey who are going to give a talk about the journey of the giant iceberg A68 and its possible impacts for South Georgia. So this evening we've got a combination of Laura Gerrish, who works in the MAGIC, the Mapping and Geographical Information Centre at British Antarctic Survey, and Sally Thorpe, who's a biological oceanographer at BASS. Laura's been at BASS for about 5 years. Sally's actually been there for a lot longer. Sally was there when I first joined BASS, actually in 2002, and I've rejoined BASS a couple of years ago. Sally is still there. So what I'm going to do is pass across to Sally and to Laura to give the presentation. We'll have some questions at the end of the talk. There'll then probably be a few words from the association's chairman, David Drury. And I'll also then just finish off for the evening with a few final words. So that's how it's going to go. So with no further ado, I'd like to introduce you to Laura and Sally.
Hey, thanks very much, Martin. Hello, everyone. I hope that you can see us all okay. It's really lovely to be here talking to you today from my home in Cambridge. It's still a bit strange doing these virtual talks, but I'm really looking forward to giving this presentation and discussing any questions you might have after. So the talk is split between me and Sally. I'll start off by giving a brief introduction about icebergs in Antarctica and A68 icebergs specifically, and then Sally will take over the second half to discuss the impacts of A68 on South Georgia's ecosystems, and then she'll briefly mention some of the work that the current research expedition are carrying out in the region right now. Okay, next slide, please. Okay, is that, oh yeah, perfect. Okay. So yeah, I'm just going to start off with a quick introduction about icebergs in Antarctica in general. So they've been tracked by the US National Ice Centre since 1978. Not every single iceberg is tracked, of course, because there would be thousands. So there are some criteria dependent on their size to decide if we track them or not. And so an iceberg has to be 10 nautical miles at its longest axis long, or recently they changed this as well to include icebergs that are 20 square nautical miles in size, and that translates to roughly about 68 square kilometres in area. These icebergs are monitored using remote sensing imagery, and the availability of this nowadays is fantastic. There's more and more satellites out there all of the time taking images of the Earth, and it allows us to really monitor them quite closely. And then finally, there's a well-defined naming convention. So in the map on the right, you can see 4 quarters, A, B, C, and D. And so if an iceberg breaks off in the top left corner, for example, it's called A. So if any of you were wondering why A68 was called A, it broke off in this quadrant, and it was the 68th iceberg to be tracked since 1978 in that region. Yeah, so that's a bit of information on that. Icebergs in Antarctica typically follow a similar route, although some, of course, do not. But they go around the coastline of Antarctica in an anti-clockwise direction, generally following these coastal currents. they a lot of them then end up in the Weddell Sea, and they get rotated around this gyre and ejected north up through past the South Orkneys and towards South Georgia. This region is called Iceberg Alley for fairly obvious reasons, because it's just full of icebergs a lot of the time. And then as they move north into these warmer waters, they typically start to melt and break up. And then on this slide as well, I'm going to just highlight the location of the Larsen Sea ice shelf, which is where we'll be looking at next. There we go, in that red box. And so this is where A68 came from, and this is what I'll move on to talk about now. Thanks. Next slide. So this is a map of the Larsen Sea ice shelf, and as you can see, it's got lots of features on it and lots of rifts, and a lot of these start near the Gips ice rise over on the right hand side of this map. A lot of the rifts have been present for many, many years, and a lot of them are stopped by this suture zone, as shown here as the blue line. This zone is an area of fairly soft ice that's got a lot of marine ice frozen into it, and it allows a bit of flexibility, and it allows the rifts to grow, but then to not propagate any further. However, the rift that caused A68 propagated through this zone, and then in 2014 it started to speed up quite rapidly and went across the ice shelf, and suddenly everyone was watching it, wondering what it was going to do and how big the iceberg was going to be that broke off from it. Sometimes it's a bit difficult to tell exactly when an iceberg breaks off. We're looking at satellite images because, of course, there's no one around to monitor it, to watch it in person. But it was declared on the 12th of July that it had broken off. This is in the middle of the Antarctic winter, so it's dark, so we couldn't use optical satellite imagery, so we had to use SAR or radar images. And these images can kind of see through darkness and also clouds and such features, and so they're really useful in Antarctica, which is a very cloudy and often dark place. Okay, next slide. So A68 broke off, like I said, in July 2017, and it was 5,800 square kilometres at the time, with an average thickness of 232 metres. It was the biggest iceberg in the world at that time, although it's not the biggest one that we've ever had by any way. That area, just to give you some size comparisons, that's twice the size of Luxembourg, over 3.5 times the size of Greater London, or about a quarter of the size of Wales, because we always like measuring things compared to Wales. Larsen ice shelf was now at its smallest known extent, and it had lost about 12% of its area, which was quite a substantial amount. A68B broke off quite quickly at the end of July, and you can see that in the top of the images here. And so that meant that the main chunk was now called A68A, because that's how the letters after the numbers work. As it breaks up into more pieces, we get more and more letters, and the biggest original piece maintains that name of A. So this image we're looking at is from September the 16th, 2017, so about 2 months after it had broken off, and you can see that it really hasn't moved that far. So in the Weddell Sea around here, there's an awful lot of sea ice that would be keeping it fairly still at the moment. And it hadn't moved far. The left-hand image is a natural colour image. You can see rifts on the iceberg and on Larsen ice shelf, and you can see some clouds that are creating shadows on the berg. And the right-hand image, I think, is really interesting here. It's a false colour thermal image. Thermal imagery has the advantage of showing where the colder ice ends and the warm, relatively warm water of the Weddell Sea begins. It also shows patches of ice melange, which you can see that it's thicker than the really thin sea ice around it, but that it is thinner, so it gives off a warmer signal than the shelf and the icebergs. So it's just a nice clear way of seeing the different kinds of ice that we're looking at here. Okay, next slide. So just a little bit about A68's journey to start with. So you can see from the map on the right hand side that it moved quite slowly to start with. As I said, this area is full of sea ice a lot of the time. So in 2018, it hadn't gone far. By 2019, it got a little bit further. So July 2019, those of you who know the location, you can see it's quite close to the sea on attacks by here, but it's still caught in pretty solid sea ice around here. So it hadn't gone far. The orange line on the map shows the medium summer sea ice extent. And then the yellow line shows the median winter extent. So you can see there's a lot of sea ice to be working with around here. 2 cruises were planned in 2018 and 2019 to go and study the area where A68 came from under the Larsen ice shelf. They wanted to look at the seabed by collecting seafloor animals and sediments, and also mapping the seafloor using sonar. This area hadn't been exposed for a long time, and it was a really unique opportunity. Unfortunately, both missions were thwarted by heavy sea ice, and neither of them reached the location, but they both went on to do really interesting work in other area. Okay, I'll now go on to talk about its movements as it approached South Georgia, which is the bit that really got the media's attention and that a lot of you might have heard of before. This is the map that I made when I was starting to track the iceberg. It shows its movements from October until early December. Everyone was starting to get worried at this stage. You can just see the size here compared to South Georgia, the main island. It's a very similar size, which is part of the reason that this one caught so many people's attention. I've got 2 other things shown on this map, which I'll just point out quickly. So I've got the southern front of the Antarctic circumpolar current. This is the route that we expected the berg to roughly follow, and it was following it quite closely at this time. And I've also got the 200-meter bathymetry, so water depth isobath. And if you remember, I said the iceberg was about 200 meters thick. And so these regions are just highlighting potential areas where the iceberg could ground or get stuck. And that was what was potentially going to have an impact on the animals and ecosystems around South Georgia. Okay, next slide. Thanks. So it made a big and important turn between the 9th and the 13th. It's still very close to South Georgia, and all eyes were definitely still on it, but at least it had turned around a little bit by this time. Okay, next slide. A slightly different map here. This one was made by NASA, and it shows the currents that the berg is following at the time. So although I said that the berg was following the Antarctic circumpolar current, this isn't an exact line. It moves given the season and time. And so this map here shows the exact currents at this time. Bergs of this size typically do follow currents like this, whereas smaller ones, once it breaks up, start to be affected by wind and more local impacts. Just for those of you who are interested, the current vectors on this map come from the OSCA model. It blends various measurements such as wind, sea surface temperature. The most critical measurement in the model, however, is the sea surface height. So ocean currents that last more than a few days will actually tilt the surface of the ocean. And by measuring this tilt with a satellite radar altimeter, scientists can identify the location of currents and estimate how fast they are moving. So it's a really important thing to be looking at. Next slide. That's okay, I'll carry on talking. The slide should catch up. So we're still looking at its movements at this time. Like I said, it was still very close to South Georgia, and everyone was still really wondering what was going to happen to it. It had gone around the corner, and at least it hadn't slammed into the south continental shelf, which we were all wondering at some point. But it was still moving quite quickly, and still had a lot of potential to kind of cause havoc at this time. Oh, there we go. Thanks, Sally. So on this image, you can see a few different things. So A68D was formed, shown here with the 17th of December bright pink outline. We think this happened as it hit a shallow bit of seafloor, so it got really close to the 200-meter lines that I highlighted on the map before. It probably hit this shallow area and a little bit broke off, but that was okay. And then on the 22nd of December, however, A68 broke quite substantially. So it produced E and F. This was its first major break, and it received a lot of attention. F broke up very quickly, and we didn't see much more of that. E, I think, is still around now, and yeah, this berg was quite a substantial size still. Okay, and then on to the last map of this style that I'll show. Thanks. This one is a big jump in terms of time from the last one. So the last one was 22nd December, and the date of this is the 1st of February. So A68A seemed to stay in much the same place for quite a while, which a lot of us weren't expecting, while some other pieces raced along the current round to the north of South Georgia. So if you can see the track of E here, which is the one up to the east and the north of South Georgia, it followed the current on this line almost exactly, which was really interesting to see. It was supposed that A probably detached from the major flow of the Antarctic circumpolar current and sat in relatively slack water between different parts of the current. It might have been more influenced by eddy features and weaker flows rather than the strong directional current. As well as showing that the pieces didn't move far, this map also shows that A broke up further. So you can see on the 28th of January orange outline that A had broken in half. And then between the 28th of January and the 1st of February, parts broke apart further, both parts broke apart further. A few people described, I saw on Twitter, a few people saying that the waters of South Georgia were becoming like iceberg soup, which is a good term, I think. It was quite difficult to keep track of the bergs at this stage and see where they were going and what they were doing. And the availability of good satellite imagery was really important. So that's the last I'll say about their tracking in this talk. Many small bits are still in similar locations, but a lot of them have moved around to the east and the north, and some have broken up completely and are no longer being tracked in the official database. On to the next slide, please. So I just wanted to highlight a little bit about why the icebergs are breaking up. So I said they had, but I haven't really said why. One of the mechanisms of their breakup is called the Footloose Mechanism. So warmer water and waves erode the iceberg at the waterline, and so the ice cliff above the water moves back, leaving a significant extension of the iceberg below the waterline. And this is called the ice foot. This term was formed a few years ago, I think. This ice foot is buoyant, and it causes the edge to flex upwards, resulting in cracking and chasming of the iceberg. It results in large pieces breaking off, as we can see in some of the images that were taken. And you can see the pale blue in these images show this ice foot beneath the water. So the photo on the left is a high resolution satellite imagery taken by Planet. And the red circles are highlighting the foot underneath the water, and then also you can see some of the cracks on top of the iceberg that have been formed. And then the photo on the right, this one was taken by an RAF plane on routine patrol in the region, and I just loved some of the images they took. They're absolutely beautiful, and again it shows the big amount of water underneath and the cracks on top with bits breaking off the iceberg. Okay, and finally on to my last slide before I hand over to Sally. There were so many beautiful maps and images created for A68. I wish I could say this was one of mine, but it isn't. This was created by someone at the European Space Agency, which just shows A68's entire track. And also it shows this historic iceberg routes. And you can see how most of them are following this exact route that A68 took, really, or at least a close approximation of it. And for those interested as well, you might notice that this is a similar route to the Ernest Shackleton endurance story. So, of course, his ship was crushed and sank in the Weddell Sea. Then him and his men made it up to Elephant Island and then crossed the Scotia Sea to South Georgia, following a very similar route to how A68 moved here. Okay, that's it from me. So I'll hand over to Sally and we'll be around after. Thanks.
Thanks, Laura. and hello everybody. Okay, so I'll move the slide on now. Right, so I'm going to talk, and I've heard more about the journey that A68 took to get to South Georgia. I'll talk a bit more about the impacts that icebergs can have on the local ecosystem and how we're monitoring that at the moment in the field. So these are some more of the photos that Laura showed from the British Forces South Atlantic Islands unit, taken from an Airbus plane on a routine sortie over the island. This one shows A68A before it broke up. It's just impossible to get a sense of the scale, I think. I cannot imagine it at all. And then this one up here shows the fragment that Laura mentioned that had broken off A68A when it turned the corner. Well, not the corner, but when it changed direction at the shelf of South Georgia. This is A68D in front of South Georgia here, and you can see Mount Paget in the distance there. So I thought one way to illustrate some of the impacts that the icebergs can have is with a cartoon or a sketch. So in the following images, what you'll see is a cross section through the ocean. And to start with, we'll imagine that this is an iceberg here, a beautiful regular tabular iceberg floating free in the ocean near an island, but not yet grounded. So to start with, the physical impacts then. An iceberg can affect the ocean from both above and below, and near the surface and at depth as well, of course, because as Laura said, they can be deep. A68 is actually considered quite a thin tabular berg, but still 200 meters is a long way in the ocean in depth. And so what we get is meltwater from the iceberg. So because the surrounding ocean is relatively warm, you get these plumes of cold and fresh water coming off the iceberg at the surface, all the way through actually, with depth and at the bottom. So because the meltwater that is released from the iceberg is cold and fresh, that means it's less dense than the surrounding ocean and more buoyant. So it'll make its way up to the surface. This means that you get local mixing. So as the water moves up to the surface, it'll mix up the water from depth. We'll get impacts from on the local circulation as well. An enormous obstacle in the water can cause changes in the ocean dynamics and the circulation. And then we get the modified air sea fluxes at the surface where the iceberg is. Obviously, it's it's protecting the sea underneath from input from solar radiation and winds, for example. It changes the albedo, so there's greater reflection of the incoming radiation. So even before we consider the ecology, we can see that the iceberg has massive impact potentially on the area. So, but now, of course, one of the things that we're interested about the South Georgia is because it's has such high diversity there, such high biomass. So in terms of physical, sort of on the more physical side of iceberg impacts, just imagining this as a big obstacle in the water, then things that can happen are that we'll get shading underneath the iceberg and at the side where it casts a shadow into the water. This can affect, together with the fresher water in the ocean, can affect the community there, so affect the types of phytoplankton, for example, that we might get. In terms of high predators, the iceberg, depending on its location, could prevent foraging access to key areas, particularly in the breeding season. And that's another of the reasons that A68 got a lot of interest was the timing of it approaching South Georgia and the fact that it was coming right in the middle of the Antarctic summer and could potentially have even stronger impacts on breeding populations of predators. And then if there's changes in the local circulation, that could affect prey delivery. We know that ocean currents are important for distributing key prey species. So any changes to the local circulation could have impacts on through the food chain. Then in terms of biogeochemistry then, icebergs carry quite a lot of nutrients. So they have this load of nutrients that they have gathered from when the icebergs were an ice sheet on the land, and they've gone over sediment, for example, or atmospheric dust has brought in nutrients, and they act as a transport these nutrients through the Southern Ocean. So as the iceberg melts, they're releasing the nutrients into the ocean. And that can increase productivity. Because the Southern Ocean is what's called high nutrient, low chlorophyll, it's got a lot of nutrients, but it's limited by iron. So these iron-rich deposits from the iceberg make a big difference to the local and further afield productivity. And in fact, it's studies on giant icebergs in particular have shown that productivity can be increased by up to a factor of 10 after an iceberg has gone through a region. And it can, this peaks at distances of between 50 to 200 kilometers from the giant iceberg. So you get this enhancement at quite a distance from the iceberg, and not just behind the iceberg as it's gone through, but also it can happen ahead of the iceberg. Because these, this water that comes off is buoyant, it'll get to the surface, and the surface currents are stronger, faster than the currents at depth. So often what happens is this buoyant plume will travel in advance of the iceberg and can increase productivity ahead of it. The other thing that about icebergs and where they come from is that they have different sediments, different nutrient loads because of the underlying geology. So those that come from the A sector, where Laura showed you, so including the peninsula and the Weddell Sea, the underlying geology there is more easily weathered. I've read, I'm not a geologist, than other parts of the continent. And so they are known, there have been studies that have shown that icebergs from this region are particularly enhance the local chlorophyll as they go through a region. And so once you get increased productivity in an area, then that can have impacts through the food web. And often you'll see increased foraging around icebergs, for example. So that was with the iceberg free floating. But of course, one of the risks of icebergs is that they could ground. And as Laura showed you, there's quite a lot of area around South Georgia that the potential for grounding of these icebergs. Some of the bigger chunks have missed South Georgia and the shelf and have carried on past. But there are pieces that are on, A68D, for example, although it's smaller than it was when it broke off, it seems to be loitering around the shelf at the moment. And so what happens when an iceberg runs aground is that it catches on the seafloor. It's so thick that it can, it rests on the seafloor, and icebergs can be grounded for several months or longer in a place, depending on the local currents and how quickly it melts. So what that means then is that brings additional impacts. So one of the most devastating natural disturbance events is iceberg scour. So the iceberg, as it moves along the seafloor, will take out anything that's on the seafloor. So all animals that are there will be ground up, basically. And also, as well as that, it can, depending on the underlying geology and the sediments, as the iceberg goes over, these sediments can be mixed back into the water column. So that can add nutrients back into the water column, but it can also suspend carbon into the water and upset the sequestration processes there. And of course, if an iceberg grounds, then it's all the other impacts that we've talked about are still happening, but they're now concentrated in a particular area. If an iceberg's moving through as it melts, then it's still giving inputs, but if it's grounded, they're in one place. And also, as we've seen with A68A and how it broke up so dramatically, there's now a lot of smaller pieces of ice in the water. So we're getting a massive input of fresh, cold water into this region. Yeah. So those are some of the impacts then that we expect from icebergs. And what I'll talk about now is how that how we're monitoring that now in the field. So the passage of A68 has been, it's just provided so many opportunities to study what these icebergs do and the paths they take. And now we can look at the effects that they have on the ecosystem too. And so how we're monitoring it is a tale of satellites, ship, robots, and local heroes in the form of penguins. So I'll start with satellite data. This is a website that I've spent quite a lot of time looking at as A68A approached South Georgia. It's the European Space Agency Ocean Virtual Laboratory. And it's one of a number of websites that provide satellite data, really accessible, really nicely visualized, and you can get a really clear picture of what's happening anywhere in the world with these kind of places. So here, this is South Georgia here, and the shelf around it in blue shading. This is A68A. So this is just as it was doing that turn that Laura said, as it's reached the shelf here. So this is middle of December, the 14th. And the white streamlines here are the current flow. So you can see the currents that the iceberg followed. Once it gets to this point of the shelf, the currents diverge. We get flow to the west, to the east, and some goes on the shelf as well. So at this point, we really didn't know as it was approaching just which way it would go. You can also see the currents that have then taken it forwards with time. So this is the southern Antarctic circumpolar current front here, and you can see meanders in the flow. So it goes out here, it's a loop and around, and then this strong flow along the northwest, along the northern shelf of South Georgia heading to the northwest. And here is some one of the eddies that Laura was talking about that's trapped some of the pieces. So we can measure lots of different properties of the surface ocean with satellites. I'm just showing you a couple more examples here. So the things that we can measure are temperature, surface currents I've shown, ocean colour, which gives an idea of the amount of phytoplankton in the water, salinity, waves. There are lots of other things as well. But here we've got on the left, we've got sea surface temperature, and on the right, we've got ocean colour, both from the time that A68A was making its turn. And these are the positions of A68 as it approached, going backwards in time, so for the last 6 weeks or so. So one of the things that you can see from these images is the level of detail that you can get. It's just staggering and amazingly useful for all sorts of things. So you can see in the temperature field that how the iceberg followed the front in the flow. So there's this gradient, so there's warmer water here, colder water here. And you can see as well, although there's some contamination from where the ice is, that there's colder water here around the iceberg. And if you look closely, it does look as though there's an intrusion of this cooler water onto the South Georgia shelf. And we'd expect that, that's the way the currents go. But it does show that if this water is meltwater from the iceberg, that it's heading directly onto the shelf at that point. And from there, it can circulate around the shelf. In terms of ocean colour, this is at a higher resolution. And you can see these beautiful swirls in the surface ocean. So this is from, as I said, the 14th of December. There's a lot of cloud cover and ice, which prevents the satellite sensor from measuring the ocean colour, but it still gives you an idea of the structures that are there. And what's great about the satellite data is that we've now got long time series. And so we can compare what's happened this season with what's happened in other years and see how unusual the conditions are and what might be connected to the iceberg passage. So while at the moment we haven't begun the work to untangle this as to what is the iceberg and what is just background processes, the data is going to allow us to do that going forward. Okay. So now onto the field work. So this is another map. As Laura said, there's so many maps of A68A, and we did a Google search just to check, and there was like 340,000 search hits for A68A iceberg. But the images are just amazing. This one comes from the 12th of February, so just a couple of weeks ago. And as Laura said, you can see just the number of icebergs now in the region. So these are the icebergs, some of them are labelled, and then this is cloud, and you can see South Georgia here. And so this is a situation that some of the fieldwork has been going on in. And these are a couple more of the pictures of the ice as it's broken up. So there's a lot of ice, a lot of careful navigation required by the ship. So at the moment, there's a cruise going on. This is a joint cruise between the British Antarctic Survey and the National Oceanography Centre. We're really so very lucky to be able to carry this out. It looked, well, as with everything in the last year, all the challenges related to COVID, it was, yeah, there was a huge amount of logistics went into making this happen, and it's incredible that it has. So what's gone on is that there's a small team of scientists now on board the RRS James Cook, which is this ship here. It seems strange to see a blue and white ship rather than a red and white one. So we've got a small party of scientists on, and they've combined 3 routine surveys that we do each year into one to try and keep our time series going. These long time series that we've got are just so hugely valuable for all the studies that we do at South Georgia, that we're so grateful that this could continue. So the things that have been happening are you might know that the British Antarctic Survey do a regular repeat acoustic survey on the northwest shelf of South Georgia called the Western Core Box. So the crews has managed to do that. They've redeployed 2 long-term moorings. This is one of the parts of the mooring on the deck of the ship. So that means bringing it up from the ocean floor, refurbishing the equipment, downloading the data and throwing it back in again. And those moorings sit in the ocean then for another year, recording the lots of information about the ocean over that time. And then there's also 2 hydrographic sections that are regularly done. So there's one called the A23 section, which is from South Georgia down southwards into the Weddell Sea. And the SR1B section is another repeat section that is measured from the Antarctic Peninsula to through Drake Passage to the Falkland Islands. And on both of those, they use a CTD instrument here, which stands for conductivity, temperature and depth. And that allows us to measure temperature and the salinity of the water, so we can determine the density, and that tells us about the ocean currents as well in that region. So all of those have been combined into this one cruise. And on top of that, they've been able to carry out some CTD sections and biological sampling in the vicinity of the A68 icebergs, as well as some glider deployments. So ocean gliders, these are new. So although we've been able to get data from icebergs around South Georgia in other ways before, this is the first time, I think, that we've been able to deploy ocean gliders around the icebergs. So ocean gliders, although they're not a new technology, they're a brilliant tool for oceanographers. They're a really cost-effective way of sampling the ocean for longer than a ship can stay there, and at times of year when ships are not there. So they're remotely operated, and they're driven by batteries. So this is one here being lowered into the ocean with one of the A68 fragments here. And so you can see it's on a cradle and it's tethered to the ship at the moment, but that's to retrieve the cradle, that's not for the glider. So the glider goes into the water and it's piloted remotely. It gets instructions from the satellite and then follows a predetermined track and samples as it goes. And because of the way it moves, it uses buoyancy changes to go up and down through the water column. It's very efficient and they can be in the water for months at a time, which is just great news. So it was a very rapid funding to enable these to be taken down. So very quick decisions made on the funding, which are just brilliant. So the glider deployments have been funded by the UK government Blue Belt programme, the government of South Georgia and the South Sandwich Islands, and the Natural Environment Research Council. And that's allowed us to get the gliders down there and the satellite costs in transmitting and piloting the instruments. And these are gliders from the National Oceanography Centre, who were just brilliant at turning them around so quickly. It was quite a quick window of time to get them ready to get south in time for the cruise, and they're there and now are in the water. So this is what the gliders do. They go from the surface to depth, and the ones that are in now are going to 1,000 meters depth. So they're giving great data coverage, and they do this sawtooth pattern. And every now and again, they'll come back up to the surface, they'll transmit some of the data back and their position, and they'll get a new set of instructions and carry on their way. So the ones that we've got are measuring temperature, conductivity again for salinity, and chlorophyll A, and some other biological parameters as well. And the good thing about them, because they're in contact with the satellites, is that they send their data back in near real time. And that's good for research, and also the data goes into forecast models as well. So in terms of the cruise track then, it's quite a complicated map, but I kind of like it because it shows just what the ship have been dealing with down there. So this is the cruise map here, part of the cruise track, and this is the inset area here. So here is South Georgia. This is the 200-metre isobar and the 1,000-metre isobar. And the black line is the cruise track of the ship. And the colours are the positions of the icebergs, as Laura was showing you. So the green are the most recent ones from the 16th of February, back in time to the paler ones. And so you can see that the ship have done various turns and had to manoeuvre around ice. Ideally, when we plan the cruise tracks, they're straight lines, but it's never quite the way in the Southern Ocean. And then so they've had to wiggle around here and here. So and these photos are from the cruise, so it's ranged from foggy to beautiful blue sky days. These are the CTD stations, so that's where the CTD has been lowered over the side to collect information on the temperature and salinity. We've managed to do a lot of those. These are two sections approaching A68A, and this is the A23 repeat section that I was telling you about. And this is the 14th time now that it's been occupied since 1995. So it's a really good data set, and coincidentally, right next to where all the icebergs are, so we should get a good signal of any iceberg impacts when we compare the data between years. And the gliders were deployed here, south of A68A, and here north of A68A, so that we could see the impact of the iceberg as it passes through. This glider is approximately here now, so after 10 days or so, it's travelled about 100 and nearly almost 200 kilometres and taken around 40 profiles, which is, yeah, great data coverage. And the plan is that the gliders will be in the ocean now until around about May time and be picked up with the South Georgia vessel, the Pharos. And so to complement the marine work, there's ongoing predator studies as well. So we've got the long-term monitoring that we do on South Georgia with the British Antarctic Survey for higher predators, and that's been complemented with some drone work. This is a picture that John Dickens took, and I think if any of you heard John Dickens' talk to the South Georgia Association, he talked about using drones. This is a picture of a king penguin colony here, and as well as that, there's drone surveys of the gentoo and macaroni penguin colonies, and some GPS tags have been deployed. Sorry, that's an oceanographer speak. Are on the penguins so that we can track their foraging patterns and the trips that they make from their colonies. So from Rookery Bay, there's 18 macaroni penguins have been tagged, and from Hound Bay, 18 king penguins have been tagged. And so the information from those will help us see how the foraging trips might change in the presence of an iceberg. So getting towards the end now, what might the future hold? A68 generated a lot of interest, and a lot of us gave interviews to the media. And one of the questions was, is this a sign of climate change? What's the future bringing? Well, giant icebergs carve naturally on decadal timescales, and we don't think that the carving of A68 is linked to climate change. These things happen anyway. But models are predicting that in a future warmer Antarctica, there will be more icebergs carved from Antarctica. They may not all be giant icebergs, but because of how ice sheets are thinning, and that's what this map shows, it shows the areas of largest increase in ice flow into the ocean. So the red dots show where the ice flow is increasing the most. It's published recently. So, so understanding more about what changes icebergs can bring to a region, and such catastrophic collapses we've seen with A68A in the region, will help us better understand what the future might be like. And also, as Laura said, the information that we can get from observing giant icebergs such as A68 breaking up are applicable to ice shelf breakup processes. So what drives, for example, Larsen C breaking up. So being able to study those, and at such resolution with the data that we've had and the images, means that we can better constrain models, for example, as to better predict how and why ice shelves might break up in future. So now that A68 is moving through South Georgia and we're starting to lose some of the parts to melting, there is one more iceberg to watch. This is currently the world's biggest iceberg. It's A23A, and it's, if if you can just see this tiny inset, it's here in the Weddell Sea at the moment. It was carved in 1986, so it's already spent a very long time in this thick pack ice in the Weddell Sea. But if you wanted another iceberg to follow, this could be the one. Whether it'll make it to South Georgia and on what timescales, we can't say, but maybe it's one to look out for. So to summarise, A68 has been the focus of much interest globally, and related to that, because A68 has been in the media, so has South Georgia, so there's been a lot of interest in this part of the world. This has been due to the unprecedented amount of satellite data that's available now. It's easily accessible, it's frequently updated. We've been able to follow this iceberg in so much more detail than other icebergs in the past. With the satellite data and the fieldwork that's going and the long-term monitoring series that we've got, we're well placed to gain a greater understanding now of the impact of icebergs on the South Georgia marine ecosystem. There's going to be a lot of work ahead to process the data and deal with this, but it's a good position to be in. And the dynamics of giant iceberg breakups such as A68 give insights into ice shelf collapse processes, and that's important for climate modelling. And that's that. Thank you very much for your time. And if you've got questions, please do feed them through the magic of YouTube. Thank you.
Thank you very much, Sally. That was fantastic. And I think there's probably a big virtual round of applause for you and Laura coming through the YouTube channel as we speak.
I can feel it.
We've had lots of messages coming in, and hellos coming from Patagonia, USA, Canada, Netherlands, Transylvania, Chile, Scilly Isles, New Zealand, and Italy. So people listening into this from all over the planet, which is great. There have been a few questions come in, and I think probably there's a couple for Laura, and then perhaps one or two for you, Sally. So probably the first one that's come in for Laura is, how do you predict the routes of icebergs? And that's from Ahi Shah.
Okay, hi. Yeah, that is an interesting question. I'll start off by saying I'm not actually an expert in that topic of iceberg route tracking at all, but it's mainly just the currents. So we can look at the currents as they traditionally are and as they currently are. Like I said, there's general trends that are quite predictable, but they do change a little bit with season and with different conditions that might affect it. So it is mainly looking at these currents. Sally, do you have anything to say? You know more about currents than I do.
So yeah, it's true. Particularly the giant tabular icebergs, are very much driven by the ocean currents. The smaller icebergs have more impact from the winds, and the smaller scale currents, as Laura mentioned in the talk. There are a number of models now that are in development and have been used to predict iceberg trajectories. Giant iceberg modelling is more of a recent development and ongoing. But the other thing that we did with this one was look at the past icebergs. Because we've got such a great database of the icebergs that have been tracked historically going through this region, we were able to look at the ones that had gone to a similar position as A68, and that gave us some confidence that it would, it gave us a range of probabilities that it might get close to South Georgia, and as it got close to South Georgia, we could redefine that envelope of possible trajectories.
Thank you, Sally. And probably another one for Laura, a question from Roger Chambers. How do you obtain satellite images? Do you have to pay NASA or ESA, or where do you get them from?
Oh yeah, interesting question. I just guess I didn't cover that. Most of it isn't paid for, so the amount of freely available satellite imagery nowadays is just absolutely brilliant and makes a lot of our jobs a lot easier and makes the possibilities a lot better. So the European Space Agency have a whole suite of satellites, the Sentinel satellites, and I talked about the radar satellites that can see through clouds and darkness and everything, and they're from the Sentinel-1 satellite from ESA. They've got a Sentinel-2 and 3 satellites, which are optical, so more normal like colour images that are all completely free. A normal user can go and view them quite easily online in a few different places, and then a mapping or remote sensing specialist can work with the raw data to extract a lot more information out of them. And NASA, you mentioned as well. Yeah, NASA have got an awful lot of free imagery as well. One of their main satellites, Landsat satellite, provide endless imagery, which is just absolutely fantastic as well. And they've got ones that cover the Earth more regularly. So every day that they'll provide us images, and these are some of the ones that we were using mostly to track these icebergs. But the resolution of them, the spatial resolution, is much lower, so you can't see as much detail. But an awful lot of it is free. There are still, just to finish, there are still satellite images that you have to pay for. So the really high resolution ones that get down to like 30 or 40 centimeters, you know, the ones where you can actually see individual penguins and whales and seals and stuff, you have to pay for them. But we haven't used many or any of those ones for this project.
And we should say as well, Laura, I forgot, we did have a slide, and I think it got culled as we had to cut back on the amount of information we had. Polar View is another great website as well, which if you go to polarview.aq, that shows you what data are available, and you can get a lot of the images. It tracks, you can find the iceberg tracks and some of the images that we've shown on the slides here as well. So that's another good one to look at, isn't it, Laura, I think?
Yeah, absolutely. Good idea to mention that. Yeah.
Thank you both. And I think this question is probably for you, Sally. Does the SACCF move around much in different seasons? And you mentioned Shackleton as well in the talk. And are you saying that the SACCF hasn't changed, moved, or weakened significantly in over 100 years? And that's coming from Anne Leaney.
Yeah, that's a great question. So the Southern ACC front is one of the fronts in the Antarctic Circumpolar Current. There's a number of fronts that these jets have, and so they're gradients in the temperature and salinity properties, and associated with them are current jets. And often with these jets in the Southern Ocean, they're tied to the bathymetry, so they'll follow areas of slopes in bathymetry. But in the Scotia Sea, once you get away from the Antarctic Peninsula, it's relatively flat, so you can meander, the currents can meander more in the Scotia Sea before they then reach South Georgia and then wrap around the shelf like we showed in the satellite image. So there is movement on a number of timescales within a defined band, and we've been looking at that for quite a long time. In fact, data from different animals with tags on, so from elephant seals, have shown us how much the front can move around. We haven't got a lot of data to say where the front was in 100 years ago, but well, Shackleton's a great example. We can see that the general flow of the Antarctic Circumpolar Current, even if not this specific front, was still northeast across that region, luckily for Shackleton, and got him to safety.
Thank you, Sally. Next question from Alan Jones. Is there a size above which the bergs will not flip over?
That's a tricky one. It depends completely on their shape. So it's absolutely amazing sometimes how these icebergs will, how they will sit in the water, basically. It's to do with physics that I won't pretend to understand, unfortunately, but there's, a center of mass, and these big tabular ones, I don't know, they'd have to lose quite a bit, I presume, Sally, like A68 would have to lose quite a bit of area, wouldn't it, probably, before it might flip over.
Yes, when it's a massive sheet, then it's very stable. But as soon as it breaks, then you can see there will be flips. And in fact, in some of the images that have come back from the RAF and the higher resolution satellite images show some that have flipped over onto their side. So yeah.
Right, thank you. And the next question from Jeff Ball. Have there been many serious collisions on South Georgia? And how far north is A68 likely to go?
There have been a number of icebergs that have grounded on South Georgia. There was one that hung around for several months. We were looking back at this, I think in 2004 and 2012, there's images of icebergs on the South Georgia shelf. So it's not an unusual occurrence for them to come this way, for certain, as Laura showed with her maps of the historical routes. And we can tell from surveying the seafloor as well, where icebergs have been, you can see the grounding marks of them. So yeah, so that's happened before. I'm sorry, Martin, I've forgotten the second bit of the question.
Yeah, how far north is A68 likely to go?
Well, the further north you go, the warmer the ocean is. So, and once you get beyond South Georgia, there'll be rapid melting, really. The polar front, which is another of the fronts in the Antarctic Circle called polar current, it's quite a strong surface temperature gradient associated with it. But that also, so there's very warm water once you get beyond that. So I think once they're past South Georgia and around, there's a loop in the currents that goes along the northern shelf to the west and then back north and east. Once they're caught up in that, then I would expect them to melt before too long. But I don't know for sure. I haven't actually looked to see how much further they've gone than South Georgia. Have you, Laura?
No, you don't often hear about them after that, which, yeah, perhaps supports that answer that they won't survive much longer, probably.
Mm.
I'm not sure who's best to answer this one, but a question from Jean Tadlock. As A68 was approaching South Georgia, did they prepare for any type of evacuation, as it seemed to be moving rather fast?
Well, so the only people on South Georgia at the research stations on the northern side, and they're well protected. And although there was a lot of talk in the media about a collision with South Georgia, the iceberg wouldn't get to the island itself. It would ground on the seafloor before that. As Laura showed, the continental shelf sticks out from South Georgia for a long way, and the iceberg would run aground on that before it got close to the island.
Thank you, Sally. Another one that's probably not your area of expertise, but I'll ask it anyway. It's how long would a benthic community take to recover from a grounding event? We could do with Dave Barnes being here to answer that one for us.
Yes. Oh, I feel like that's a question I should have revised for. And I meant to. I think it can take a long time, can't it? I mean, Martin, you probably know. I mean, yeah.
Yeah, I mean, a lot of the communities on the seafloor are fairly slow growing. And but then again, a lot of these places probably do get fairly regular scouring. There are places certainly that are subject to a lot of ice scour and are able to recover quickly. If the iceberg hits a place that has got a more stable, longer term fauna that are very slow growing, it will take a long time for that to be replaced. So I think it will vary depending on the type of benthic animals that are down there. Right, now a question from Robin Isherwood from north of Bolton. Do we think the penguins on South Georgia have been affected by A68 in the last few months, or is it too early to say?
Well, part of the world have come from the north of Bolton. I don't know. So that's the beauty of the long-term monitoring that we do, is that we will be able to compare the success of this breeding season with other years. And then it's a case of, we were saying, as untangling what's the impact from the iceberg and what's other variability that's going on in the region. I mean, Martin, you're more familiar with the penguin work that's going on.
Yeah, I mean, I think we have seen this summer season has been a poor season for the Gen 2 penguins on South Georgia. We don't know what the cause of that is. It could be related to A68, but I think until we properly look at all the data, we won't know for sure. So yeah, the Gen 2s have not done particularly well this year on South Georgia. It'll be interesting to see what the macaroni penguins and the king penguins that have been tracked, what they do, see if they behave any differently, because we have had tracks of those species at this time of year in the past that we can compare to what we have now. But yeah, the Gen 2s haven't done very well this year, but we're really not sure what the cause of that has been. And that's been an effect pretty well across South Georgia this year. But the Gen 2s are, they do seem to have that, they either seem to do incredibly well, and the adults will raise two, certainly more than one chick and sometimes two chicks, or they'll just do very badly in other years. It's a sort of binary sort of response from the Gen 2s. Okay, a question from Inspiring Tour Leaders. What happens in the area the iceberg broke off from in terms of any significant impact to the local ecosystem? Would that amount of ice be gained over time? So I think this is probably referring to the area on the Larsen Sea that the shelf or the A68 broke away from.
Mhm.
And I think Laura did mention the attempts to get down there by the Polar Stern and the James Clark Ross a few years ago. Laura, did you?
Yeah, I did. I don't know if they have studied it much because they couldn't get there, but it would affect the ecosystems, absolutely. These the seafloor there hadn't been exposed for, do we know, since, I don't know, thousands of years probably. The Larsen is now at its smallest known extent. The second half of the question, would that amount of ice be gained over time? So yeah, we now expect the Larsen ice shelf to grow again. Like as Sally mentioned, I think it's all a cyclical event. So these carvings do regularly happen, and then it grows out again, and these areas will get covered. But of course, we've got the climate change issues, which are affecting how quickly and how often things like that happen. But do you anything to say on the ecosystem, Sally?
Yeah, I think what you said was true, that it's the sudden breakup of it, and well, we didn't move away that quickly, but still the gaps would let light into areas that wouldn't have had like that level of light for a long time. So it would have been a big change, and that was why the research cruises were so keen to get in there to be able to measure that. For, you know, it's not often there's a chance to do that, and unfortunately the ice stopped that happening.
Another question, and I think we'll call a halt to the questions fairly soon and let everybody escape, but a couple more questions have come in. From Richard Slesser, great presentation, many thanks. Is there going to be any tracking of elephant seals as well as penguins?
Not on South Georgia, right, Martin? Is that right?
No, at the moment we've actually just started doing some work of using drones actually to do counts of some of the elephant seals on South Georgia. Sally did mention some of the work that's been done by putting oceanographic instruments onto elephant seals, and that was done from Husvik a few years ago by the Sea Mammal Research Unit up in St Andrews. But there hasn't been much work on tracking of elephant seals for a while on South Georgia, apart from that oceanographic work. I think, yeah, I mean, it would be interesting, but I mean, we can only do so much, I think, at any one time, given the funding we have.
Yeah.
Right, a couple more questions from John Barker. Oh, it's just for information. During the BAMT voyage in early 2015, we found numerous tabbergs off southeast South Georgia, grounded around Cooper Island and shelves right at the mouth of Drygowski Fiord. Our experienced captain never seen so many. I guess that's just an indication that they are coming in onto the shelf at South Georgia sometimes.
Yeah.
Well, what I'm going to do, I'm going to call a halt to the questions now and say a big thank you to Sally and Laura. I knew a little bit about A68 before the talk, but I know an awful lot more about the provenance of the icebergs and what they can do following that talk. So I hope that's been the same for all of you in the audience. What I am going to do is just, well, anyway, just a really big thank you to Sally and Laura, and then invite David Drury, who's the chair of the South Georgia Association, just to say a few words to wrap up.
Sorry, Martin, should I stop sharing my screen now?
Yes, please, Sally, thank you.
Yeah. Okay.
Well, thanks very much, Laura and Sally, for that really outstanding discussion about the iceberg around South Georgia. I seem to remember learning years ago that the most furtherly north icebergs had been reported at 33 degrees south, which would put them off Brazil. And I think also in the records, there's that huge iceberg that broke off the Troll's Tongue called Trolltunga, which was south of South Africa in Dronning Moorland, and it was the size of Belgium. And I think it's the biggest reported iceberg that ever broke off the Antarctic continent. And I had a Belgian friend who said to me, he said, you know, if it breaks up into two pieces, we'll have to decide which is the Walloon bit and which is the Flemish bit. But that's a Belgian story, I guess, that we can all appreciate. Well, look, everybody, it's been a fantastic evening. I really appreciate what everybody has said. Let me just, at the end, say that those of you who are members of South Georgia Association, of course, this is part and parcel of what we deliver for you. For those of you who aren't members, let me just say a few things about the association before we finish. We have several hundred members, we're 20 years old, and we have, along with everybody who's, I guess, viewing, a real passion about South Georgia. And we love to share all of that together when we hold events. And so we know whether you've worked there or whether you've traveled there or whether you just look at books and photographs and imbue yourselves with this fantastic island, South Georgia Association is there to really support you and your interests. We have several events a year. We have events at various locations, all the way from Edinburgh, all the way down to Plymouth in the United Kingdom. And we often meet in Cambridge with meetings with the Friends of the Scott Polar Research Institute. And we're also in London where we have our spring meeting. And that's a mixture of a little bit of AGM, but also a reception when we can all get together and chat about our experiences of South Georgia and share mutual friends and comments and thoughts about this place and the South Atlantic generally. And we always have a lecture, a short one about something to do with South Georgia. So typically we also have a newsletter which is published online. We have a new website which you can use, but the newsletter is for members that keeps you up to speed with what's going on. And of course, you can find us on Facebook with lots of things that are being there, photographs and stories. All of these things keep the members of the association up to date with what's going on. So if you're really interested in joining us, sharing South Georgia, then look on our website and sign up and join, and we'll be very, very happy to see you on some other occasion. In the meantime, I just want to say great thank you for all of those wonderful stories about our friendly South Georgia iceberg, and to wish you all well, and once again, good luck to all of you who have plans or thoughts about South Georgia in the coming months and years. Let's hope some of us can get back there. Thanks a lot. Good night.
Great, thank you very much, David. And that just leaves me to say good night and thank you, everybody, and stay safe. So thank you, good night. And thanks again to Laura and to Sally.